Okay, so this is one of those situations, I don't think I discussed this in any of the classes, but this is one of those situations where you just have to think and you'll be able to figure it out. Like, you know u is probably going to be either 3x plus 5 or x squared plus 10x plus 4. So, like we did on some of the previous examples, we said, well, when I take the derivative, which one am I going to get? Well, if you look at the exponents, you see this x squared, right? So take the derivative of this, you're going to get just 1x. And this 10x is just going to become 10. So it stands to reason that this is where we want to go. Okay, I know that there's more at play than just the exponents. Like, we will have to factor in the fact that this is 3 and 5, and this is 10, and this, well, when we take the derivative, it'll be 2. But let's cross that bridge when we get there. So let's go ahead and let u equal x squared plus 10x. So du dx equals 2x plus 10, which means du equals 2x plus 10 dx. Now, we have a little bit of a predicament here, because normally I look here and I see some version of this here, and I don't see that here. Well, I don't see exactly that here, but what I do see is that if I factor out a 2, I get x plus 5. And if I look here, I have 3x plus 15. Yes, I had originally written 3x plus 5, but it was supposed to be 3x plus 15. Okay, so I made a mistake. Make sure you realize on your homework it says 15. I had written as 5. So what I want you to see here is that, notice that in this one, if I factored out a 3, I get this, right? And now, when we look at this, we have an x plus 5 here, and we have an x plus 5 here. Now, the rest of this is still dx, and this is still du. Okay? So, what am I going to do? I'm going to move the 2 to the other side. I'm going to have du over 2 equals x plus 5 dx. And because x plus 5 dx is this portion here, this problem, I really didn't write this right. This is a dx on the back. And a dx here, I can put this and this together, and that'll be du over 2. So let me rewrite this. So we have the integration of 3, the square root of x squared plus 10x plus 4 times x plus 5 dx. Okay? And now when I substitute du over 2 here, and if I substitute u as x squared plus 10x, actually I made another mistake here, I apologize. This should have been 10x plus 4, right? So then I can plug all of this in. I was preoccupied with this, but it's really, you want to set it equal to all of this. This will become 0, so it doesn't really matter. What am I going to get? So I'm going to end up getting the integration of, I'm going to put this a little lower here. I'm going to put the 3 on the outside. We're going to have square root of u times du over 2, right? And I'll just piggyback off that, put it on the outside business, and put the 2 on the outside, so I have 3 halves u to the 1 half times du. Okay. And so now, if I integrate, I get u to the 3 over 2 times 2, well, kinds of messed up here, 3 over 2 plus c, which gives me 3 over 2 times 2/3 u to the 3 over 2 plus c. This is kind of cool because all this cancels out. So I'm left with u to the 3 halves plus c. But again, we're not solving for u. We're solving for what u is. And we know from the beginning u is x squared plus 10x plus 4. So this is going to be, u is going to be x squared plus 10x plus 4 raised to the 3 over 2. plus c. And that's my final answer. Okay? So hopefully that made sense. I apologize. I made a couple of little silly mistakes when I first wrote the problem and then when I did the u sub, but hopefully that's clear now. So again, the idea is that you want to u sub this entire amount so that when you break it down, you get an amount that you can work with. The big new move here is that I factored out the 2, so that I had the x plus 5, which is where we have the x plus 5 here, if you factor out a 3. Okay? So you're going to have to do a little factoring. Hopefully that makes sense, and I'll see you all in the next video. There's our final answer.